Okay. Um, and some audio. Hopefully my audio is being picked up by the correct microphone. Let me check that. Audio, audio, audio. Okay, I think everything's good. Okay, so I've made some progress in checking if a dead end has been hit. That's not quite the right way to put it, I think. Checking if backtracking is needed is kind of a different way to put it. So it's not at all a tidy approach, of course, but here is let's see, walk through maze with user input takes the two-dimensional character array, which I'm beginning to regret instead of using a vectors because partly because the of the way that it's represented in local variables. If we go to the way a two-dimensional character array is shown here is just where is it? The window pane for local variables is what I'm looking for. It's kind of interesting and confusing how this stuff pops up, especially if you don't pin it and you hide it and stuff like that. So if the already visited grid is okay, that makes sense. Two-dimensional character array. The maze. Yeah, if we open up the maze here, it's I guess maybe the way it handles booleans is different. Hmm. The maze is a two-dimensional character array, as you can see right there. And it's just annoying that something about the way it's stored in memory or it's annoying that the zeroth row can't be expanded here. So anyways, um, I'm gonna scooch that to the other laptop screen. Okay, so we have a loop that executes while we are not at the end. We've got a grid of Booleans with the same dimensions as the maze, and it keeps track of whether or not each, each position in the maze has already been visited, excluding walls. We can't visit walls because if we try to visit a wall, that triggers the character above character to the left equal the wall character that I'm using is here. So we don't let them update if it's a wall. We don't let them. The update to the already visited array it occurs at after the reading of the inputs, WASDF or WASD or C to clear the screen. That's where the update happens right there. After we um, update the current row and current column or current column up above, like right here. Okay. So previously, if we got down in this well right here, this restriction, the already visited equal true, would prevent us from going up to this position because we've already visited that position. But if we don't want to end up in an infinite loop or just lose the game due to inability to foresee the future, we need to be able to move up. So the circumstance right here is that the number of walls the number of neighboring walls is, if you were in this location, is 1, 2, 3, and okay. So if the number of walls is 1, 2, 3, then you've reached a dead end and you have to backtrack. So at the beginning of, near the beginning of each iteration of the loop, I determine the character above, below, left, and right. I make a vector of neighbors, which I kind of just did for convenience, but there is, that's a bit of a dangerous thing to do because it's not clear necessarily what order the neighbors are in. Is it above, left, below, right, or whatever permutation of that you want to take? So we call check if dead end hit, and that was what I wanted to look at because I'm at a point here where I wanted to talk, because the path that I took to get to the current position is down, up, here, here, here. I came back up successfully, and then I went to the right. And if you try to go down at this point, my code doesn't allow you to go down at that point because you haven't yet explored this path. Once you get back here, um, I also haven't accounted for that scenario where the number of already visited, you only have one neighbor right here, one neighboring wall, and then we've already visited here and here, this mouse, and here. So the number of visited neighbors is 3, and the number of neighboring walls is 1. So I'm about to modify that. But let's see. And I think, yeah, we're in that same scenario here too. I attempted to go to the left using A on this previous iteration, and I can't go to the left because my is dead end code isn't detecting that this needs backtracking. But what I have handled, I got this neighbor is wall function, which I used instead of for the standard library algorithm count if. There we go. Count if takes the predicate here, so instead of doing the lambda syntax stuff, which I don't understand or enjoy particularly much, I just made a function here that returns true or false, a predicate. Again, the syntax is a little bit strange. Usually if you do this, if you say cout neighbor as well without parentheses, it prints the memory address of the function. Something like that. That's another thing I haven't verified. Okay. Let me delete that. Okay, so the number of neighboring walls, this should make sense. Okay. The number of visited neighbors cannot visit a wall also. Okay. So this is having, if we visited the guy above, we increment the number of visited neighbors by 1. The one to the one below, we increment the one to the right and the left. Okay. And these can't be else ifs because we don't want to exclude one of these. We want to check all of them. We can print the number of neighboring walls, which can be useful. So if the number of neighboring walls is 3 in the 2-dimensional case, it must have been the case that if we're not at the end point here, well, if we're at this position, we have 2 neighbors. We don't regard this, we have 2 neighboring walls. We don't regard this as a wall. So I think the only circumstance in which we could have 3 neighboring walls is in a 2-dimensional grid where we can only go up, right, down, left. We've already visited the guy above. Another situation in which that could be true is, I don't think I have any on this grid, but it's, if we rotate this 180 degrees or 90 degrees counterclockwise or clockwise, that creates another instance of that same scenario. Okay, so now if the number of neighbor, this is a scenario, if we, initially I had, if number of neighboring walls equals 3, return true, and I just had a return false, this return false after that. And when I hopped back up to this position, I had two neighbors, so two neighbor walls. So this condition evaluated to false. So I printed this message saying that I had not hit a dead end, so to speak. Need to come up with with a more accurate way of describing what this scenario is. It's not a dead end, it's a need for backtracking. Just loosely speaking, it's okay. But in this case, the number of neighbor walls is two, one, two, these two guys, and I visited this guy previously and this guy previously. So that's just here. Else if number of neighboring walls is equal to 2, if the number of visited neighbors is equal to 2, then return true. There's no other else if within this block. I guess I'll leave that. This is my sort of hard-coded approach earlier. I'm not sure if I need to do anything further with this cycle type scenario. By that, I mean going around in a circle like here, going round and round over and over again. I don't think that I don't think that other possibilities need to be accounted for in this else if, in this two-dimensional case, at least. I think that this is the only, if you have two neighbor walls, you can't have 3 visited neighbors because there are only 4 neighbors in each position. So you got one position and 1, 2, 3, 4 neighbors. And in the event that the number of visited neighbors is equal to 1, you haven't reached the dead end yet because you could still explore the other avenue. So yeah, a scenario of that, an example of that is coming down here, down, and at this position, we have 1, 2 neighbors, and we visited one neighbor, two neighbor walls, and we visited one neighbor. So we can still go to the right. Okay, so no need to backtrack yet. I suppose we could be explicit and say else if number of visited neighbors is equal to 1, return false. But it's not necessary, I don't believe. Okay. So I need to get back to this scenario and handle the case where I'm just getting distracted by in the event that we go down here, here, up, left, down, up, right, down, down. It seems like it would be nice to give the user the freedom to go back down this path. But part of me is saying that just because I know the solution is down here. But if we force the program to take the right path before coming back, I guess that just makes sense in the event that we have different graphs, different mazes. Okay, so what is this scenario? I'm locked out right now. There's a wall where you've already been there, and the I haven't shown that yet. The logic of the walkthrough maze here is if it's a wall, we don't let them update their position as we do right here, C for current position, and the else. So if this is true, or if it's already been visited, and which is a critical part here, they have not hit a dead end. if it's already been visited and they have hit a dead end, then we let them execute the else. Because otherwise they can't move anywhere, which is the case here. I can't go, let's see, can I go down? No. Continue. I paused it. Okay, and it applied code changes, so it's dangerous. Can I go down? S, no, no. Can't go down, can't go right. And I can't go to the right because I've already visited that position and I'm not picking up on the fact that I'm at a dead end. Okay, so let's stop and come up here and just see if I can turn this out real quick. So I meant to look at this scenario. We have one neighbor wall. So we've got LCF number of neighboring walls is equal to 1. And I guess, is there any need for an else here? There's not. But is it obvious that that's an else? Either the number of neighboring walls is 1, 2, or 3. There is no possibility that the number of neighboring walls is 4 because that means you cut through a wall and ended up in a hidden area in a game, an invisible wall. So it's not a very nicely designed maze. There are 4 walls here, obviously, but they're if you're at a position in the maze where you're surrounded by 4 walls, that's an impossible situation to escape. Okay, so 1 neighbor wall, and we visited 3. Yeah, we visited this position, and this position because we came up out of the well to the right. So we visited this guy, and then we went down. So we visited this guy up, and we visited this guy as well. So I think it's just simple. You could do this as an and as well. And number of visited neighbors is equal to 3. But maybe there's some advantage to, like if I have additional conditions inside of here, maybe there's some advantage to just doing an if inside here. Turn true, and by true, it means a dead end has been hit and backtracking is needed. And that's obviously bothering me so much that I'm wanting to change the function name. So I guess since I'm doing that, so it's not I just wanted to show the red text color, this escape character, escape sequence. I don't know what the /033 is called. It's okay. But it's nice to make this stand out. Hopefully this doesn't break my code if I rename this function. Maybe we just say need for backtracking was detected. Uh, We'll allow it for this turn. And dead end, dead end, dead end is an aggressive message. Number of neighboring walls is equal to 1, and I wanted to rename it. Check if backtracking needed. Check if backtracking needed. Okay, and don't give a name to that boolean, but I did name that boolean and it hit dead end, so rename it dead end, as in hit dead end, backtracking needed. What do I call that function? Backtracking needed. Yes, backtracking need. Backtracking needed, replace there, replace there. Backtracking needed, replace there and there. Be really nice to be able to do this in a way that didn't look so ugly, of course. Seems you've hit a dead end, allowing backtracking for this turn. Why did that get executed? We've got you just set a breakpoint. Am I still recording? Yes. Can I hear myself? Hello? Yes. Okay. So where do we? I'm getting congested in this space. I'm gonna move my code over and stop sharing and do a new share of the bigger screen. Hello, hello. Okay. Didn't do any work on this backtrack method, just got confused and irritated by it. Maybe we just set a breakpoint right below the main function. Right in the main function. Here's our initial maze that we printed. And let's step in. Already visited grid. I had I think this already visited grid. Yeah, you see all the values are true here. So that's I suppose it's got to be initialized to something, and this is the danger of not explicitly initializing. Earlier, I didn't have this nested for loop where I'm explicitly setting everything to false. So let me step over this. Oh dear, or step out. Where did we go to? We're expecting input. Step out went all the way to the prompt. Okay. I figured step out would step out of the loop, not or in, so we wouldn't have to. Okay. Step over. Oh dear. Let's So you can put a breakpoint there and then continue. I think that should get us, okay, thank you. All right, so already visited, we got a bunch of falses. Um, just checking that I'm sharing correctly. Okay. Okay, and one of these falses is about to get updated to a true. Yeah, right there. Okay. Whoops. Jesus Christ. Is it really unpleasant? Oh, copy paste there. Okay. Let's close that. So we've got move count equals 0. While loop condition is going to be true. Get the character above and the character below. We get the neighbors and we check if backtracking is needed, which evidently it was needed a minute ago. And why is that? Let's see. Already visited grid gets passed in. The neighbors get passed in who are a wall above, empty space below, a wall. So we've got 3. The move count is 0 right now, so this if shouldn't. I think, all right, it'll just get triggered in this case. I didn't pass in the move count here, and I would rather not do that. So I suppose I can just ignore that for the first iteration. I think that was why that happened. Yeah, it should be. Yeah. Here I handle what's causing that to be displayed. It shouldn't be saying the need for backtracking was detected. It just says you hit a dead end. This is the only scenario at the start point whenever we could have possibly got to a position with 3 neighbors and we didn't come from the other neighbor. All right. Let's step into that. Okay. Now, neighbor, there's that predicate getting executed. Number of neighboring walls should be 3, and it is. And we're going to find the number of visited neighbors, which should be 0. And the moment it's uninitialized. Let's check that. 0, no increment, no increment, no increment, no increment. Okay. It is 3, so we printed this. Okay, so let's stop and go back. Remove breakpoints. See how this goes. Again, the thing I'm testing here is this handling of this situation. So if we go down to the right, up, down, or left, down, up, back over here, over here, over here, over here, I wasn't able to proceed past this point because I only had one neighboring wall and I hadn't accounted for that possibility as I have right here. Return true in that case. Okay, have I removed my breakpoints? All of them? Maybe. Okay. No, I didn't. Line 540. Okay, that's not accurate. It'd be nice to handle that, of course, but I'll do it later. D, that's a wall. To the right is a wall. To the right of C is that wall right there. I'll make this nicer in a while. Okay, and now it still says we've hit a dead end. Okay. Go down, 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 right, 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 right. It's a wall. C to clear. Okay. Right, it's a wall. Okay, C to clear. Let's not go down yet. Let's go up. W, W. Let's not go right. Let's go up. up, right, left, or left, left, down. Now, if I attempt to go up at this point, it shouldn't let me because I haven't visited the down path yet. There's a wall or you've already been there. No backtracking allowed until a dead end. A human, obviously, in this maze, depending on the distance at which they could see, they would see that there's a wall right there, and then they would immediately turn around. They wouldn't take one more step forward. So that's an interesting thing to think about. I attempted to go up when I was at this position, back to this position. And I won't be allowed to. And that gets into what they call the heuristics. Heuristics. I mean, being able to look ahead and see that in two spaces there's a wall, which is more complicated and probably maybe is getting into that A-star algorithm. So let's go down. Okay, now it says it seems you've hit a dead end, and that is a dead end. Okay. The previous step was not a dead end, but it's okay. Allowing backtracking for this turn. Need for backtracking was detected. Both of those lines got printed. Okay, so let's see. Can we go down? If we try to go down, that's a wall. Either there's a wall or you've already been there. There was a wall down of this current position, S. And we also printed again that we hit a dead end. And we're printing that every time, even if we clear. Okay. So let's go up because we can and we have to. And still the need for backtracking was detected because the number of neighbor walls is 2, and we visited both of these positions. That is, both of these conditions are true. The number of neighboring walls is 2, and the number of visited neighbors is 2. We visited this guy, and this is a wall, and this is a wall. So we can we will be allowed to select W. We will be allowed to select W. So which of those conditions is not true? It's not a wall. It has already been, this is equal to true, but the backtracking needed is set to false in this case, true in this case. If we pause real quick, backtracking needed is set to true. Oops. Let's continue. Oh my God. Continue. Okay. It's expecting input. And this is true, so not true is false. So true and false yields false. And false or true. False or false is, Jesus. If the character above is equal to a wall, which it is not. All right, yeah, I don't want to take forever, so. Okay, we can still revisit a previously visited position. And also in this case, we have 2 neighbor walls. We visited this guy and this guy. So still the need for backtracking is detected, meaning we can revisit previously visited positions. So we go to the right. And still, the only, we could take 2 steps. I guess we could go to the left. Yes. That's kind of interesting. Can we go down and down? Yeah. Okay. So we could Obviously, you go bounce quite a lot back and forth. If you take random steps, that's unlikely to happen. But that's interesting and worth being aware of. I'm obviously not sure how to fix that possibility. Okay, so we go to the right, and now there is no need to revisit a previously visited position because we have another option where we visited this position. And if we attempt to go down, it won't let us. Okay, you've already been there and no backtracking until, I need to change the wording here until dead end, until it's mandatory or something like that. Yeah, I guess until dead end is actually correct in that case. So if we try to go down, it won't let us. Okay, so we can only go right, and we just went right, right. If we try to go left, it won't let us because we'll be backtracking without until we've encountered the need for it. You've already visited that. There's no wall right here, right to the left, obviously, of the current position C. Okay, so we go right. Let me clear and let me go down. Okay, down, down, down. If we try to go up, we can't. Okay. If we go right, we can go right, right. If we go left, we can't go left because we haven't explored the up path yet. Up, 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 and then left. And now something is happening that didn't happen earlier, so it's catching the need for backtracking in this case. Now I'm getting thrown off because there are two neighbor walls here, so maybe the problem was at this point. Can't remember now. A need for backtracking is still detected. So we could still also get caught in a loop and backtracking is needed for all of these positions. There we go. And all right, so I can go left. Okay, and I have, and still I'm revisiting previously visited territory. So now is another sort of moment of truth, which is, I think, yeah, so now I'm finally testing the code that I just wrote. But earlier I was actually, oh, here, yeah, right here, I was testing one neighbor wall and three previously visited neighbors. So this, okay. And now it's the same, it's a similar scenario. We have one neighbor wall and we visited this position and this position and this position, right? And it's saying need for backtracking is detected. So we go down, all right, down. Now we can go to we don't need to backtrack anymore. There's no more red text here because we have a path that we haven't explored. We can go to the right, right. What if we go down? I think if we try to go down, we see an error. Yep. You've already been there and we haven't explored all possible paths. To the right, if we try to go left, we shouldn't be able to. Okay, go right, down, down, down. Okay, let's test going the wrong way again. Let's go to the left and down and right instead of getting to the goal, but eventually we'll get to the goal. I also like to try to go back up here. If we go up or down, we could try to go up. It refuses, right? Yes. Left, left. Now, what about up? Up should be refused because we haven't been to the left here yet. Up is refused. No. Oh, because we haven't visited that. We hadn't visited this guy yet. Okay. So now we could revisit previously visited positions, which is good. We go up, we'll still see that message. We can go down and down. Now We have a pass we haven't visited. Left, left, left. Can't go up. So I haven't tested this scenario yet. Okay, now you've hit a dead end. Okay, still backtracking is needed, 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 needed. Okay, now let me try to go right and then up. It refuses. Okay. And down, down, down. Okay. 128 moves. Okay. So let me pause the recording and I'm going to fiddle around with the automated getting the computer to walk through this with the subject to these rules. Probably will take a while.